All right.
Yeah. Where's the fire alarm in here?
Number one.
Are we going to do every single one of them?
We're going to give it our best shot, Becca. Whether we're going to be able to or not, I just don't know. All right, so one thing that you guys need to be aware of for the test for the first four of these problems when you have to do the identities, none of them are going to use like the double angle stuff. Bobby, on the desk of my stuff.
That's fancy.
It's just going to be the basic Pythagorean identities and the sine and cosine stuff and the factoring and common denominators, and so we're not getting super crazy, okay? So 1 plus tangent squared, you remember, is what? Secant squared.
How do you guys know this?
So I'm going to change 1 plus tangent, because I did it yesterday, I'm going to change 1 plus tangent squared into secant squared. And your hint there is the whole squared thing. When you see a squared thing, then you probably want to do one of the 3 Pythagorean identities, okay?
Secant squared, okay.
Okay, now I'm going to change everybody into sine and cosine. So secant is 1 over cosine. Cosecant is 1 over sine. And tangent is sine over cosine.
So you just turn it all this.
Yep, turn it all into sine and cosine. Using the fundamental identities. Very most basic ones. Yeah. Okay, now I'm pretty much done.
Why is it squared?
Because the original thing was squared.
Okay.
Because if you have a fraction divided by a fraction like I have on the left, what do? Multiply by the reciprocal, so I'm going to take 1 over cosine squared times sine squared over 1, and that is going to be sine squared over cosine squared, which equals sine squared over cosine squared. And that's that.
Wait, what did you do?
I went this, 1 over cosine squared,
Times
times the reciprocal of this. So I went 1 over cosine squared times sine squared over 1. And that gives me that. Reciprocal, R-E-S-P-E-C-T. Who says what there when? Okay, give me your phone.
Yeah.
Yeah.
You take the meet too.
Staff meeting on Friday, big slam down on the phone.
That's what I heard.
Yeah. Recording already.
Yeah.
Okay, so we're good there?
That was crazy.
Reciprocal. I think.
Wait, why should the 1 times 1 over 4 times 4 times 5?
Because when you're dividing 2 fractions, the way you do it is you multiply the top one by the reciprocal of the bottom. Okay? All right. Number dose.
So just
Go back, please.
secant.
Go back for a split second.
Hold on.
Hold on.
Secant over
I'm not doing it now.
Go back for a second.
Okay, next one.
secant over cos.
Your clue is that you have no squared things
So
in
you
there.
just don't.
Okay? So we don't have to do any Pythagorean. You got it? So there's no Pythagorean things that you can change anything into, so we're just going to go right into the change everything into sine and cosine.
Oh, yeah.
Yeah, so tangent is sine over cosine. If it's squared, it would be, but it's not squared, so it's not. Cotangent is cosine over sine. This already was sine over cosine. Okay, so what do you want to do now?
Oh, you
I do if I have a fraction divided by another fraction, but I don't yet have a fraction divided by another fraction.
One plus one over sine times cosine.
Well, don't the one
Wait,
just
wait, wait, wait,
cancel
wait,
out?
what?
Multiply one plus sine x over cosine times cosine.
So you want to cross multiply basically? Okay, so Becca's going to take this whole thing and this whole thing and multiply that by cosine and this by sine. She's cross multiplying. Two fractions are equal, you can do that. Because there's an equal sign between them. They could be lying.
It happens all the time.
Are you lying? Okay, so I have to multiply both of these things by cosine. So what's 1 times cosine? Cosine. What's sine over cosine times cosine? Sine, because the cosine cancel.
Why did cosine?
Because I went sine of x over cosine of x times cosine of x. So,
Those cancel and this sine of x.
and I left the sine of x.
Why did you have cosine?
Here,
Yeah.
because cosine times 1 is cosine.
Okay.
Okay. All right, same thing now going this way. So sine has to go times both of these things. Sine of x times 1 is sine of x. Plus sine of x times cosine over sine is cosine, because this sine and this sine will cancel. When's the last time the sun was out? Anybody remember?
3 days ago.
Saturday, a little bit?
I saw it.
Remember in like October, September,
Yes. Yes.
Mayor, what?
asking for rain.
That's right. I had to delay that. That's right. Okay. What do you want to do now?
Well, we need to change all that into,
You want to?
yeah.
Okay.
That's what we're doing.
Sure. So let's change all of this into.
1 over secant squared. Oh.
Don't be ridiculous.
I was doing the first one.
Or can't you minus
Why didn't you do the
cosine?
No, we're done. We're good.
Why didn't you do the cosine first?
Because I want to get everything into cosine and sine. I thought that's what you meant when you said change everything into.
Oh, okay. That's what I mean.
Okay.
No.
Cancel the cosine. Can't you minus cosine minus
Yep. It's sine squared. Which is awfully convenient. I'll have to wait for everybody to finish writing this down.
Okay, so then we're gonna multiply those, right?
Yeah, so what do I get when I go sine
You get
squared?
sine squared.
Right, the cosine squareds cancel.
Okay, that was easy.
So that leaves me cosine squared plus sine squared equals 1. And if there was one thing I wanted you to
That's what
learn
you
from
wanted
this
to know,
entire
that equals
chapter,
1, right?
that's it. That's 1.
We have that in our notes somewhere.
Should.
Yeah, that's right there.
Sine squared plus cosine squared equals 1.
that one.
No. I'm going to make one in there that's wrong, just for Taylor.
Wrong.
Because he said sometimes they could be lying.
Oh.
So I just put one up there that's not true, and then you can spend like a half an hour.
That's always way harder than
Okay.
So can we change all of our tangents into that?
Sure, sines and cosines.
Yeah.
That seems to have been working so far.
So sines.
Oh. Okay, change everything into sines and cosines. Why?
Would it just be,
No. You could times everything by cosine squared and get rid of the cosine squared on the bottom, so you don't have factors anymore. You want to do that? So we times everything by cosine squared. So sine squared over cosine squared times cosine squared, what happens to the cosine squared?
just sounds great.
So cancel, and this leaves you with sine squared. Minus sine squared times cosine squared is sine squared times cosine squared equals, what happens to this cosine squared and that cosine squared? Cancel, so sine squared times sine squared is sine to the fourth.
Oh, because.
And sine squared times sine squared is sine to the fourth.
Oh, because they cancel out.
Cosine squared is
So you did
cancelled
two
out.
steps in that.
True.
So you-
Yeah, hold on. Okay, now what? Back out a sine squared over here, okay? Back out a sine squared over here, so that'll leave me 1 minus cosine squared equals sine to the fourth. One minus cosine squared equals what, Ashley? Sine squared, so I can rewrite this as sine
Oh,
squared
they
x
equal the same thing.
sine squared x. And as we talked about before, sine squared times sine squared is sine to the fourth. And we're done.
Was there an easy way to do that one?
No, that's pretty good. Well, you and I did it differently, right? We got a
Yeah,
common
way
denominator.
harder.
Yeah, that was a little bit more difficult.
I'm just gonna check out taking the sign and cosine.
That's not a bad way to go. All right, so now we're into solving triangles.
I like trying.
So 35, 15, and 50. So solving the triangle means we need to find the 3 missing pieces. What you got for me? Law of sines, because I have an angle and a side across from it. So that's an obvious. Okay, so first you can say C is 95. Because you know they have to add up to 180, obviously.
Sine of 95 over C.
Yep.
Okay.
Cross multiply and divide. 26.1. Okay.
Okay, I got it. I guess I did that.
Oh, what'd you get for that one? What? 20.0.
20.03.
Easy peasy, right? Yeah.
Those ones are. But like number 7 or number 6 and 7 have to use cosine.
I don't know. Can we get all the way through with the law of sines on both of them?
But it doesn't give you.
I think for number 7 you're going to have to go cosines.
Why does it have S and T's?
Why wouldn't it?
I think I should have the lock, isn't it?
Okay, that would be good.
I guess we don't have those
Law size, finding.
Okay, number 6, we can start out with law of sines to find the angle this time. So sine of 45 over 10 equals sine of b over 4. You guys remember how to do this? You cross multiply and divide, but the answer that you get in an angle b is the sine of the angle b, so you have to go inverse sine, and you said you get what, Cows? 16.4 degrees. I thought that was b. That everybody got?
Yeah.
Can I go?
Hold on.
Hold it.
Yeah, well, okay.
Next to the rear.
Where is this?
No.
Is this from last chapter, Elder?
What is it?
This thing?
Yes.
Good. Is that on the after?
Yeah, that's from my side.
You try to find an angle as the 34 square degree. So this is this triangle. Okay.
Well, let's try it. Let's try it. Let's try it. Okay, so this time, since we know the 3 sides, we're going to have to go law of cosines. So we're going to find angle S first, just for funnies. 34 squared equals 18 squared plus 20 squared minus 2 times 18 times 20 times the cosine of x. Right?
What do you do with that cosine x?
Why do you have a 20 for your last name?
Whatever, S, because if
No,
we're,
why do you have cosine? What is that? Where do you put that?
it's times at the end. That's
Why do you
what-
have a 20 at the end?
Because that's what the formula says, it's minus 2 times this one times this one. Okay?
Why are my being specific here?
I didn't do. So 34 squared is 1156. 18 squared is 324. 20 squared is 400. And then 2 times 18 times 20 is 720 cosine x. Okay?
I also got
You got 4 for what?
And then you have to subtract that from 34.
What do you mean you got 4? Time out. No, no, no. You went 324 plus 400 minus 720?
no.
Yes. And that's how you got 4? No, these are connected to each other. You can't do that. These are not like terms. This thing here and this
Oh,
thing
okay.
here can't combine with that because that has a cosine in it and these don't.
So add those two together.
Yeah, so I have to get those over to the other side.
So what were
That's
for the other one?
150.
Okay, you are not going 324 plus 400 minus
I didn't,
720.
I put.
Oh, I just typed all that
increase.
top thing in like.
Oh, but it's times cosine S, so you can't do that. You have to combine these two things first
That's what
and
we're
do this
doing, that's
later.
what I'm doing.
Okay? So what I have to do is I have to go 1156 minus 324 minus 400 first. So that means I have 432
Right, I got that.
equals. So what do I do to get rid of this negative 720?
Why did I did 18 squared plus 20 squared, I got 17.
That's correct.
Why do you have 3?
Because I did them both separately. But if you add them together, you get 720.
So we have to divide by,
So I'm going to divide both sides by negative 720. It's what? Negative 0.6 what?
Negative 0.6.
That's it?
Well, we have to do the inverse.
No, I'm just surprised it came out to be such a clean decimal. So then you go second cosine of that and you find out angle S is what? It's what?
126.
I got 126.
126.9?
Yeah.
You have second cosine of negative 0.6 and you got a negative answer.
yeah, 1.
No,
That's wrong.
not sure.
Wait, so how do you get
That's
the?
Now we can use the law of sines to find the other two. Yeah, but since you started us out smartly with this obtuse angle, we know these two are going to be acute, so we're okay. If the angle that you're looking for is obtuse, then you have to use the law of cosine. Okay? So, yeah, so always find the biggest angle first, and then you'll be okay.
I already know.
Cross from the biggest side. So sine of 126.9 degrees over 34 is equal to the sine of t over 18. T is what?
Why didn't you do anything in alphabet?
Because I'm doing t and 18 is across from t. Yeah.
I thought you were going to do log sines.
Right, we were just talking about that. You're okay using the law of sines as long as you're not trying to find an obtuse angle. And since the angle we found first was obtuse, then we know the last two are going to be acute. And so law of sines we're going to be okay with. But if we had found this one first, and then we were trying to find this, we would need to use the law of cosines. So what I was telling Taylor is good plan to always find the biggest angle in the triangle first, because if there's going to be an obtuse angle, that's going to be it. And then you'll be okay after that. So what did you get for T? 25.1? Okay, and then you can do the add up to 180 and find the last one. What is it? To 152, 28-ish. Okay.
Find the area of each triangle.
Really easy.
When did we do that?
Probably when you were gone. Courtney what? Oh, big surprise. Okay, what am I going to do first here? Can't do the law of sines because I don't have an angle and an opposite side. So I have to do the law of cosines, and I'm going to use to find that side right there. I'm going to go a squared equals 30 squared plus 20 squared minus 2 times 30 times 20 times the cosine of 60. Now you can type that in just the way it is, because the thing you're solving for is over here, so these are all just going to work out.
I feel like these are really.
Yeah, when you have to find the opposite side, they're really easy. We're finding this side right now.
And then once you have the opposite side, you can do
Log
log.
cosine.
Then you can do log sines just to find.
Can you?
Why couldn't you?
Because what if it's an obtuse
Well, what
angle?
is that? Okay.
Yeah, it is dumb. Yeah. How do you know? Oh. So what'd you get for A? 26 point what, Patricia?
So you say you can just type all that in your calculator?
Yeah.
Why?
Let's just skip the 12.
Yeah, because everything's filled out, there's no variables over there. The only reason why you couldn't do that with this one over here is because there was a variable on that side. And so you can't mess with that. So A is 26.5. So we don't know now if it's going to be an acute triangle or an obtuse triangle, so we better use law of cosines again. And I'm going to find the biggest angle in the triangle because it's across from the biggest side. Okay, so I'm going for side C, or angle C. So 30 squared equals 20 squared plus 26.5 squared minus 2 times 20 is 26.5 cosine of C.
So we can't do that.
Can't just type that all in because I have a variable here. So I have to figure out what this stuff is first, subtract it, divide by that, second cosine.
I think I understand.
I hope so. So what do you get for C, somebody?
Wait, you have to do that?
Yeah.
Because you don't know the top.
You don't know what kind of, this could be 100 degrees, and if you do that using the law of sine, you just get 80 degrees, which would be wrong.
Really, they're all there. That
This inverse sine only gives you angles in between -90 and 90. Cosine gives you 0 and 180.
No, the top.
How come we could have done it on 17?
What's that?
How come we did it on 17?
Because on number 7, the very first angle that we found using the law of cosines was obtuse. So we knew these would not be. I hope what I'm telling you is right. I'm not really sure.
Are you, it's
C equals 79.1. Okay, so we could have used law of sine. Okay, and then you add it all together, subtract from 180, and you get B is what? 40.4? 40.4? 40.9? You got one.
So like one point law signs is wrong now.
You could end up with the wrong answer. They have to add up to 180.
40.4.
Oh, so here.
40.9 plus 39.1 plus 20.5.
It doesn't add up? Your story doesn't add up. 60 plus 40.9 is 100.9 plus 79.1 is 180, isn't it? Okay. Never mind. All right, so I got 58 here. Okay, so what do we got going now?
Well, we should find A.
We already know
We
A.
know A, sorry.
We should find B.
We should find B.
So we're going to go sine of 58.
Why are you doing that?
Why wouldn't I do that?
It could be obtuse.
No, because I'm right, because I have opposite side over.
Could I use the law of cosine now?
Uh-huh.
And it would be better.
Yeah.
Let's be honest.
Why are we better?
Yes, just a law goes
I mean, serious is better.
top notch. Okay, cross multiply and divide. Take the second sign of the answer, and what do you get for angle B?
Can you put all the triangles on it better?
Doesn't work?
Exactly.
Okay, so when you cross multiply these and then divide by 5, you get a number that's bigger than 1. So when you try and do the second sine of that, then you have issues. So we have no triangle. Is that true? Yeah? Okay. So when you get a little error, that means you got no triangle. Whatever. Quiet down, assistant TA.
So the next three, we can use just law of sine on all three, right?
Uh-huh.
Because they all have an equal and
That's right. Okay, so number 10, they give you the same information, but side A has changed. So will this work? Okay. So what did you get for angle B? Because when we,
yeah.
and then if you go second sine of that, you get an error.
Okay.
It's not listed on the.
What do you get for angle B? 73 point what? Are you good with 73.5? Good.
So we can find C. And
Okay, so we can find angle C because we can do the 180 thing.
And then do like 58. Sine 58 over 11.
Right. So what's angle C? $48.5?
Divided by sine 58. I got 10.5.
10 point what?
1 5.
You guys just think a lot of signs.
Uh-huh.
Well, I said 1 5, not 1 5.
Why did you put the greater sign in front of it?
That's the angle sign.
Gotcha.
Okay. However, since we started out with side-side angle, there could be two triangles.
Side angle,
And then the other thing, the way that you know is it says if two triangles exist, solve both of them. So that's a good clue that you should check to see if there's a second triangle. So the way that you do that is you take the original angle B that we found, subtract it from 180. What do you get? Okay, so this could also be 106.5, okay? If angle B was 106.5 instead of 73.5, but everything else that they told us was the same, in other words, this is gone, and this is gone,
With the angle of B.
then we can figure out what angle C is because 58 plus 106.5 plus C has to add up to 180 again. So what do you get for C?
Do we have to find all that?
And so if it's over 180, then it doesn't work, right?
Right, yeah, which I think it'll be on the next one. But what do you get for angle C? 15.5. Okay, and then now that you've got that, all you need to do is the law of sines again to find out what the new measure of side C would be. So sine of 58 over 11.5 equals sine of 15.5 over C.
I understand this stuff. It's like the first step.
Yeah, the identity stuff. Never, ever, ever in 20 years of teaching taught that to a class in any time. The identity stuff.
Maybe you should teach it.
Maybe it's my fault.
Like, make it easier, just like skip it.
3.6?
Like, seriously, who knows?
Yeah, who needs to know that?
Who knows the average?
Who needs to know this science? Where those are two angles work?
Ooh, Got a big triangle. All right, so we got side angle again.
Well, that one's over. I thought you.
Yeah. So we're going to find angle B. So sine of 110 divided by 125 equals sine of B over 100. Cross multiply, divide. You say no, it's going to be here? When? Why? I think that's garbage. I got 4 guys going.
How many guys do you think?
I don't know, but you guys are just giving us types.
They want a 40.
Softball is like the whole, that's the whole team of, it's like 30 kids. Well, that's a different discussion for that. Whether they should be, you know, bird going to say or not is different than whether you guys should skip school. How are you gonna, like, what are you gonna do? Are you gonna either watch them wrestle or are you just gonna?
That was real fun.
Okay, what do you get for angle B? 48.7. Okay, so then same thing as before. Now you figure out what angle A is because those all have to add up to 180 degrees. So angle A is what? 21.3. And then you do the law of sines to figure out what side A is, and you get what?
48.
One more time? 48.3. Okay, now then we need to check and see if there's another triangle. So if instead of B being 48.7, if it was 180 minus 48.7, what would it be? What would it be?
It would be 131.
131.3. But then if we added that onto the measure we already had for angle C, we would be way over 180 degrees, so there's only one triangle.
And now we have to find the area.
Yeah. Okay, so 12, 13, and 14 are super easy. We're going to use Heron's formula for number 12. So the semi-perimeter is
That's Karen's formula right there. I did not.
half of the perimeter, and the perimeter is 14, so the semi-perimeter is 7. So that means the area is going to be 7 times 4 times 2
Yeah, half of your
times.
14, half of your 7.
So you count
I
all
just
the-
added up the sides.
Oh,
the
just
perimeter.
add them up?
Yeah, perimeter, all the.
Would you go?
I'm recording it so you can go slow.
No, not this.
Only have 8 minutes left.
I don't know why you chose 7.
Well, look at the problem.
Okay.
What's the perimeter of that triangle? Okay, and half of 14 is 7. Okay, semi-perimeter, half of
Is
it.
that what the F stands for?
Yes,
Yeah. I was supposed to know
because I taught it to you last week.
that. No, you didn't. I wasn't here.
Oh,
And
well
didn't-
then you should have gotten the notes from somebody when you were out
And you
there.
didn't record it either.
Well, you should have
What
gotten
kind
the
of
notes
teacher
from
are
somebody
you?
out
Just
there.
you should have like came to school. I'm sorry,
Yeah,
Evan.
should have come to
I'll
school,
be perfect
like
like
Patricia
you.
did. Okay, what's the square root of 56 then? 7.48?
Yeah, Evan.
Okay, number 13 has an angle in there. So that means we can't use Heron's formula. That means we're going to use the other one.
What did we just find here? Yeah.
Oh, I think this is when you guys went out for football. No, no, that's not that. I don't know when this was. Oh, 6 a.m.
And where were you yesterday after school? Because like your room had all the lights on.
Basketball game.
So you just leave your classroom.
No, he was at
He left.
You
What's your
could.
Jerry?
You could, but this is, no, it's Terry Perry.
No, what's the guy with one arm?
Mike.
That's someone.
Reno's brother.
Reno's brother. That's right.
That's not Reno's brother.
Yes, it is.
Okay, so if you have an angle,
Yeah.
if you have an angle, then you use the different formula, 1/2 AB sine of C.
You know where that guy is?
And what do you get?
What's Reno's last name?
Reno.
Wait, it's Mike Reno?
22.
What's Reno's last
22
name?
point what?
Mike
It's
Reno.
23 around.
What's Reno's last name? Reno? Oh.
Okay?
What's Reno's first name? Mike Reno.
All right, and then number 14.
Okay. Oh my God.
Just
Couldn't even figure out
turn
freaking
your board
12.
off. Just turn the board off. It's fine.
What's the answer to number 14?
I don't know.
Look at it.
Oh, wait, 7.
No, 16 to 15.
No triangle. Because if you take the smallest two sides, 7 and 15, and add them up, you only get 22. And the small two sides have to always be bigger than the biggest side. That's a trick. All right, number 15, parallelogram. Shocking the number of you that asked me what a parallelogram
I
is.
can not.
Sides of 15 and 24 feet,
He's being
and an angle of 40 degrees. So we need to find the length of each diagonal.
Why
Okay,
aren't they?
you ready?
Can't we make it?
Yeah, you kind of have.
Yep, so diagonal makes a triangle. So I need to find
Aren't the
that.
diagonals just going to be the same?
No, in a parallelogram they're not. It's farther from that tip to that tip.
No, it's not.
Yeah, it is. This is squished. These are way farther apart than those two. Okay, so how do I find D?
Well, we have to use the,
Yeah, log cosines. So D squared equals 24 squared plus 15 squared minus 2 times 15 times 24 times the cosine of 40.
And then you just type all that in.
Type all that in.
And then you use that answer.
No, tell me what you got first, and then we'll talk about how to get the other one.
Can we just search this number guy real quick? I saw one of those guys.
What? 15.8.
That looks like a little glass.
Okay, so that's one of the diagonals, but the problem clearly states find both. So now I have to find that other one there. Okay, so if this is 24, then what's
I
this?
got an error when I did
15. Okay, and then here's the OSQ, and then here's the kicker. This is a little geometry review thingy. If this right here is 40, what's that angle right there?
60.
Isn't the other one 40?
What?
120.
140, good. The Georgian gets it, okay? Because these two lines are parallel because it's a parallelogram. So these two angles are going to add up to 180 degrees. So if that's 40, then this is 140 right there, okay? So now we have a new triangle, so you got to focus in on this red triangle right here. And that's going to give us the other diagonal in the same way that we got the first one. Okay, so if you do the same thing the other way around, you get 36 points. Okay?
I'm not done.
All right, last one is the word problem. I'm sure you guys can all figure that out on your own, right? Okay? Yeah.
Tucker's got it, obviously, back
He
put
has
away.
got it, yeah, he put away stuff about 3 or 4 minutes ago. And
36.8. I got